1.6, a library of parent functions. So we're going to look at all the different parent functions. We're going to look at their name, their equation, and their graph. You're going to need to have these three things memorized by early next week so we can take a quiz and see what you know. So we're going to start with a constant function, which is just y equals some number. I have a c here. And the graph of a constant function is going to be a horizontal line. Next is linear, y equals x. This is the parent linear function, so it's going to be a line that goes diagonally through the coordinate plane, cutting through quadrant 1 and quadrant 3. Quadratic function, y equals x squared, is going to be a parabola that opens up and the vertex is at 0, 0. A cubic function, y equals x cubed. Okay, so it's going to look like an upside down parabola on the left hand side and then a right side up parabola on the right hand side. So it's kind of a curvy S shape. Next is a square root function, y equals the square root of x. The square root function will always start at a point and go up and over or down and over, and it will continue going on one side, but it will always start at a point somewhere. Next is a rational function, y equals 1 over x. Remember, rational is when it looks like a fraction or it has an x in the denominator. So a rational function is going to have a couple of different sections to it. Sometimes it can have 2, sometimes 3, but it's always going to have some asymptotes in the graph or places in the graph that it will never touch. Absolute value, y equals the absolute value of x. Looks like a V shape that's always positive. Next is the exponential, y equals a to the x power, so the variable is in the exponent. Okay, so this exponential function is going to look like it's getting really, really close to some horizontal line. In this case, it's the x-axis, and then it's going to be going up probably drastically fast. You're going to have some big numbers usually in an exponential function. Logarithmic, y equals log base a of x. Logarithmic and exponential functions are actually reciprocals of each other, so it's kind of like the flip over of an exponential function. A logarithmic function is going to have a vertical asymptote somewhere where it's going to get really close to. Next is a piecewise function. A piecewise function consists of pieces of several different types of function. For this one I did x and x squared. It looks like the graph of y equals x when the x's are less than or equal to 0, and it looks like the graph of x squared when x is greater than or equal to 0. Next is a step function, or the greatest integer function. Y equals the greatest integer of x, and when you graph a greatest integer function, it's going to look like stair steps. And it's going to have a solid circle on one side, a horizontal line, and then an open circle. That means any number in between those two values, if it's 5.5, negative 5.2, it's always going to go straight to that line. There's no in-between value, so it's going to be somewhere on the line, and then it's going to hop up to the next value. Okay, so what we're going to do with the examples is I've just picked a few of these that are new equations that you probably never put in the calculator and show you a few tricks on how you should type those in and how we would graph them. So example 1, we have y equals 2/5 times the square root of x plus 5 plus 3. So on all of these problems, we're going to make sure that we draw a table with a subsequent amount of points to be able to graph the function. You don't want to pick just 1 or 2 points because it's not going to give you a clear picture of what it looks like. So pick as many as you need to make a clear picture. Okay, so I'm going to draw my table. When I type this into the calculator, I'm going to use parentheses. Make sure you close parentheses after the 5, and then plus 3. So when you go to your table on this one, you're going to notice there are some values that have errors. And usually an error is going to indicate that there's an asymptote or a hole in the graph, somewhere that the graph does not have a value for x. So these are the values that I picked. And you just want to kind of spread your points across. You don't want to pick too many that are close together, especially on functions like this where the points, the value's not changing a whole lot. You notice that in the y column, the values are all 3s and 4s, so I tried to spread the x values out a little bit. So once you pick your points, you're going to plot those ordered pairs and then connect the dots. Always look back at the graph on your calculator as well to make sure that your graph matches the calculator. And then I need to see some actual points plotted in a table. I don't want you just to look at the calculator and then just squiggle some line on the graph. Okay, so this is a radical function or a square root function. Okay, next on number 2, this is a rational function. So when you're typing in a rational function, make sure you type the top in parentheses, divided by, and then put the bottom in parentheses. Okay, so after you've typed that in, I went to y equals or to the table and looked at the table and I picked some values. And on this one I picked quite a few values because I've got several things happening. There's a couple of places in the table where there's an error. And I want to see what's happening before and after those errors so I can make a clear picture of the graph. So I'm going to start at -6, -1, and plot these points on the left-hand side. Then I noticed at 0 there was an error. That means something is undefined. Well, when I actually look at the graph of this function, I can see that there's kind of this vertical imaginary line there. That's an asymptote. So on the left-hand side of the graph, it's getting really, really close to that asymptote, but it's never going to touch it. Then on the right side of that line, I've got other points going on. And I noticed at 3, there's also an error. Now, sometimes that indicates an asymptote. Sometimes it indicates a hole in the graph. Now, this calculator doesn't actually put a hole in the graph, but I'm going to draw an open circle at x equal -3 and just somewhere in the region where if I connected the dots, it would kind of look like it goes in there somewhere. So I actually don't know what the value is at 3. There isn't a value at 3. That's why it has an error. It's undefined. And I have an asymptote at 0. Okay, next is number 3. This is an absolute value function. So when you're typing in an absolute value, to get to absolute value, you're going to hit second 0, and it's the first one in the list. You can also go math and over to number, and it's the first one list there. So you need to do negative first, then second 0 for absolute value of x plus 4, close your parenthesis, then -2. Okay, so when I go to the table for this function, I just pick some values and plot those points. This one isn't too crazy. Whole numbers on this one. When you connect the dots for an absolute value function, it should look like a V, either opening up or down. Now, obviously, my picture here looks a little different than my calculator because the window on my calculator is different than this graph is set to. This only goes from -6 to +6. Your calculator's default window is -10 to +10. Okay, so for absolute value, just hit second 0, and it's the first one in the list, or math over to number, and then it's the first one on the list. Okay, number 4 is an exponential function. And like I talked about earlier, the exponential functions are going to be going up really fast. They're going to get some big values. So that's why the graph looks a little different here, because we're going to have some numbers that are normally off of our big graph. Okay, so I went to the table, and if you're not sure how to type this in, it's 1/3 times 6, and then you just do the raised to the power of x. So I put for these first 2 points, it's -6, 0 and -2, 0, but that's not actually the numbers that they have in the table. They have some really weird numbers that have a capital E in the middle of the number. That's the same as scientific notation on your calculator. So what that means is it's the number times 10 raised to that exponent, or that negative value at the very end. So what this means is if I move that number over -4 spaces or 4 spaces to the left, then the number is going to have a bunch of zeros before the first number that's listed. So if I rounded that to a whole number, it's just going to equal 0. So for the purposes of this graph, I just went ahead and said that -6, it equals 0, -2, it equals 0. What's happening is the graph is getting really, really close to the x-axis, but it never actually equals 0. And then I've got 0, 1/3, 1, 2, 2, 12, and if you actually scroll down, 3 is equal to 72. So that would be way off of our graph here. So I just wanted to show that this graph goes up really fast. Okay, next is a logarithmic function. So the TI-83 Plus calculators don't have the function to change the base of the logarithm. Its default base is base 10. So to get around that, we're going to type this in this way. We do the log of whatever's in parentheses, x minus 1, divided by log of the base, which is 6 in this case. And then anything else that's in the equation, minus 1. Okay, so I go to my table, pick a few values. So you're going to notice again there's some errors here for logarithmic. Now with logarithmic, what you're going to do is the first number that has an error in it, that's actually where your graph is going to start. There's an understood asymptote there at 1. And so even though when you look at the graph of this function, it looks like it just stops in the middle of nowhere, this actually continues and goes really, really close to that asymptote. Your calculator just doesn't do it. So it's going to get really, really close. Don't stop it, just continue going straight down. Okay, number 6 is a cubic root function. We didn't have this on the list of the parent functions that you have to memorize, but I wanted to make sure that you know how to get the cubic root of something. So you just type 3 times, and then if you go to math and you scroll down a few, there you're going to see a little cubed root symbol. Okay, and then x plus 1, make sure you close parenthesis, minus 1. So I've gone to my table, I picked some values from my table. When I look at the graph of this one on my calculator, it kind of looks like there's a hole in the graph. Some calculators don't show it. There should not be a hole in the graph for this function. It does continue, so it kind of looks like a long stretched out S for the cubic root function here. Okay, number 7 is this step function, or the greatest integer function. So your calculator doesn't have the double brackets anywhere in it, so to get it we have to use the integer function in our calculator. So you go to math and over to number, and then down to number 5 you should see integer open parenthesis. So math over to number and then down to number 5. X minus 3, close your parenthesis, plus 2. When you go to your table, you're going to have some ordered pairs in there. But when you graph a greatest integer function, these values are where your closed circles are going to be. Then you're going to draw a horizontal line and an open circle. So it's going to look like stair steps. Now, also on the TI-83 Pluses, if your stairs are connected, they shouldn't be connected. So go to mode and make sure you're on dot mode instead of connected mode. And then your stairs are actually going to look like stair steps that are floating out in space. When you're graphing a greatest integer function, you don't have to graph all of them that fit on there. You can just graph like 5 of the steps and then just show that it continues up and down with an arrow. So wherever those points are in the table, that's where the closed circle is. Then you're going to have a solid line, open circle, and then it steps right up and it goes to the next one. Okay, last is the piecewise function. So a piecewise function is just made of pieces of other functions. So we're actually going to put this in as 2 separate functions. And so to restrict the x values, this is how you're going to type it in. Whatever the function is, negative x plus 2 in parentheses, and then divided by the restriction, or x less than 5. And then in y2, negative x squared in parentheses, divided by parenthesis x is greater than or equal to 5. Okay, I didn't do a very good job of picking this problem because when you go to the graph of this, you actually don't even see the negative x squared part of the graph. So when you pick your values, you're going to see that for x's that are less than 5, it's going to be in a linear pattern. And then anything that would be greater than 5 is going to be in a quadratic pattern. So you notice when I went to 5, it was all the way down at negative 25, which is going to be off of my graph. So for this, we're just going to graph what we see, which is those points, and then it's just going to stop right there. And then if we could zoom out, we would actually see the parabola opening down at the bottom part of the graph.